Okay, welcome back. I know we're not doing these things in class, but this is a continuation of section 4.4, factoring polynomials. Okay, so I left you and I asked you to divide this polynomial here, this 2x to the fourth plus 10x to the third plus 11x squared minus x plus 6 by x plus 3. I'm hoping that you noticed that it was in the form of x plus or minus k, so we could actually use synthetic division from our previous section. So we could actually use synthetic division on that guy. So I synthetically divided, and what I ended up getting for my remainder here, I ended up getting a remainder of 0. Okay? So that tells me that if I put this negative 3 into this function, if I do f of negative 3, I get 0. So that means this negative 3, if you remember from previous sections, is what we call a 0 of the function. A 0 of the function. Well, since this negative 3 is a 0 of the function, then I know this x plus 3 here is a factor of the function. And again, this whole section is about factoring. So I know this x plus 3 is an actual factor. Okay? It's kind of like if I take the number, 20, and divide it by 4, I get a remainder of 0. So that tells me that 4 is a factor of 20, meaning I can multiply 4 times something and get 20. And that's really what we're doing here. I can take this x plus 3 times something and get to this guy right here. And to actually find what we would multiply this x plus 3 by, we would then divide it. So I know if I take this x plus 3 times my quotient here, then I end up getting 2x to the fourth plus 10x cubed plus 11x minus x plus 6. Okay, so I end up getting where we started. Okay, so this is really the bones of our next bit of information here, and it's called the factor theorem. So a polynomial, f of x, has the factor x minus k. So this is a factor, meaning I'd multiply this by something to get back to my function, if and only if f of k is 0. Okay, what that means here. X plus 3 is a factor because when I put a negative 3 into this function, we get 0. Okay. So we can actually use that to determine if something is a factor of that function. And again, I want you to notice that there's a change of sign here. This is x minus k, and this is f of k. So there's a change of sign there. And the reason for that is if x minus k is a factor, remember when we were solving quadratics and we'd have x plus 3 times x minus 5 equals 0. If we set both of these equal to 0, or x minus 5 equals 0, then x equals negative 3 or x equals 5. Again, do you notice that change of sign? It was a positive 3 was the factor. The negative 3 ended up being the 0. The negative 5, x minus 5 was the factor. The x equals positive 5 was the 0. So that's really what's happening here. Okay, if x minus k is a factor, then k, positive k, is the 0. Okay, so if we want to determine if x minus 2 is a factor, we need to check is x equals positive 2 a 0. Meaning when I put there shouldn't be is t there, is x equals 2 a 0. So meaning if I put a 0 into this function, if I put that 2 into this function, will I get out a 0? So there's two different ways of doing that. First, I could just put a 2 into that function. I can figure out f of 2. Okay, I could figure out f of 2. So 2 to the second plus 2 times 2 minus 4. 2 to the second is 4 plus 4 minus 4. So 4 plus 4, 8 minus 4, I end up getting 4. What we're looking for here is a 0. 0. I didn't get a 0, so is x minus 2 a factor of that? No, it's not a factor. Okay, that's one way of doing it. Another way of doing it, like if I wanted to know, okay, if I wanted to know, is 3 a factor of 7,546? Well, I would take 7,546 and divide it by the 3. I got a remainder by the decimal here, dot, 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 so no, it's not. So how did we do that? We divided it. So we could do that here. So I'm going to switch colors to show that we're doing something slightly different. Okay, so if I take this x squared plus 2x minus 4, divide it by this x plus 2. So take this, divide it by that, and see if I get 0 for a remainder. And I can use synthetic division to divide this. So since it's x minus 2, I would need to put a 2 out here. Remember, we had that change of sign. 1x squared, 2x to the 4th, negative 4. This actually goes really quick. It's 2, 2 plus 2 is 4, 4 times 2 is 8. If you notice, I get the same thing. These match, which they should, right? Using our remainder theorem from last section. Okay, we can use synthetic division to evaluate a function. So I can tell I didn't get a remainder of 0, so it's not a factor. Okay, this has a slightly, some of us might see this as being a little more work. Why would we divide when we don't have to? But this can be useful when completely factoring it. Okay, this method is useful if you need to factor it. Okay, because then I would have my quotient here. I would know what the other factor was. Okay, so next one, is x plus 5 a factor of 3x to the 4th plus 5x to the 3rd minus x squared plus 25? So I'm going to do the division method. Is that a factor of this? Okay, so then I would need to, so since it's x plus 5, I would need to put a negative 5 here. I've got 3x to the 4th, 15, x to the 3rd, negative 1x squared. Ooh, I have no x, so I need a placeholder. And then a 25 for my constant. Bring it down. 3 times negative 15. Add, we get 0. 0. Because 0 times negative 5 is 0. Add, we get negative 1. Multiply, we get 5. Add, we get 5. Multiply, we get negative 25. Add, we get 0. A remainder of 0. There's my remainder again. A remainder of 0, so yes, it is a factor. Okay. Again, the other way of doing it, if x plus 5 is a factor, then x equals negative 5 is a 0. So I can actually evaluate what f of negative 5 is. 3 times negative 5 to the 4th plus 15 times negative 5 to the 3rd minus negative 5 squared plus 25. And actually, this method looks like a lot more work, even when typing it in. Here, my numbers never got very big. Here, I'm going to have to do a lot of typing and a lot of parentheses to keep the negative 5 separated, and it'll be a whole lot of work. Okay, but dot, 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 if you do it, you end up getting 0, which tells me that since negative 5 is a 0, x plus 5 is a factor. Okay, all right, this last little example we're going to do, we want to show that x plus 3 is a factor of this, then factor completely. Okay. Then factor it completely. So not only do they want to know, is it a factor, they then want us to factor it completely. So this synthetic division method is useful if you need to factor it. Well, this problem we need to factor. So I'm going to use synthetic division. Okay, so we want to show that x plus 3 is a factor. So I'm going to synthetically divide, let's use my same color, by negative 3. Okay, so we've got 1x to the 4th. 3x to the 3rds. We don't have any x squareds. We've got negative 1x and a negative 3. Okay, so now we synthetic divide. Bring down the 1, multiply, negative 3. Add, we get 0. Multiply, we get 0. Add, we get 0. Multiply, we get 0. Add, we get negative 1. Multiply, we get 3. Add, we get 0. Okay, so my remainder is 0, so we showed that it's a factor. So, yes, it is a factor. because we got a remainder of 0. So x plus 3 is a factor. And if I multiply it by what's left here, okay, then that gets me the other factor. So let's see what's left. This is x to the 4th, so this would become an x to the 3rd. 0x squared, 0x minus 1. Okay, so there's my other factor. So if I was to distribute this out right here, distribute out, I'd have x to the 4th minus x plus 3x cubed minus 3. Actually gets me back to where we started. Okay, really what this whole process is, it's basically just like us taking the number 20 and breaking it up. We're breaking it up into like 4 times 5. Okay, but I can break up the 4 even farther. I can break up in the 4 into 2 times 2. Okay, so we're just breaking it up into as far down as we can break it up without using ones. Okay, because we don't want to use ones here. Okay, so we broke it up into this, and I want to see, can I break it up any farther? Well, you see I have a cube. I've got a cube. Well, that leads me back to my whole sum and difference of cubes idea. Okay, sorry, these notes aren't filled in. Okay, the sum and difference of cubed, a cubed plus b cubed. If I have the sum of a, the sum of b, it also works for subtraction. Okay, so it'd be a plus minus b, a squared minus plus ab plus b squared. Okay, that's already in your notes. I'm just rewriting into mine. Okay, so we've got my a and my b. So we're wanting to look, are these cubes? Well, x cubed is the cube of x. We're subtracting, so there's a difference. 1 is the cube of 1. There's my a, there's my b. So then this, again, will factor. So we still have my x plus 3 out front here. And then now we need to factor this guy that's left. So first I start by just doing the same sign. Since this is subtract, I'm going to subtract these two, x minus 1. Okay, now I'm going to square the first thing, change my sign, which goes a plus, multiply those two, x times 1, well that's nice, that's just x. Last sign's always plus, square the last term, 1 squared is 1. Okay, so there, and the quadratic that's left after a sum or difference of cubes will not factor, so this is as far as it will go. If I multiply this guy all the way out, I will get back to where I started. Okay, don't worry about doing the year-term monitoring, the monitoring progress problems. You can do them if you'd like to. There are videos. These monitoring progress problems have videos that go with them on the Big Ideas website. Okay, so if you ever want to watch other people work these problems out besides me, okay, you can always reference those. If you're stuck on a concept, you can always look at those. If you're doing a practice problem that's very similar to one of the monitoring progress problems, okay, you can watch that video. Okay, but now that you have all these done, I want you to go ahead and get started on the practice. If you encounter any problems, please come see me, see a friend, see somebody, get some help. Hey, and good luck.